Right, good morning, or I should say good afternoon. But again, I'm just experimenting with for myself to see how my lessons or presentations can be improved upon or be made more accessible or easier to understand. But there's no shortcut to hard work. That's one thing I've learned myself. Okay, so what I'm going to do is to leave you with this for now. Now I'm going to be looking at today is trigonometry. Okay. Now you're not going to be able to see what I'm looking at, but at given points in time, I will take the camera down and just show you what we are glancing at in respect of the work I'm doing. Okay. But let me just set up my camera first. Okay, let me select high definition because that's what I wanted to do. And that's what most things will be in. If it's not done in high definition, it's not going to probably run in the future. Okay, right. Welcome back. And what I want to do today is to look at. Hang on, let me just make sure I can get this up. Is to look at session 7, trigonometry. Now again, the outcome here is understand mathematical principles which are appropriate for electrical installation. Okay, standard and criteria is still the same. Now remember that although we're looking at 2357, 5357, these numbers could change, but the technical information will still be relevant, okay? That might in itself be updated as we begin to find ways of landing our ships on Mars, Jupiter, and so forth, okay? But that is way into the future. I'll be probably be long dead and gone then. But nonetheless, for now, I'm here. So let's look at what we can do. Thank you. Okay. By the end of this outcome, you will have had the opportunity to identify and apply appropriate mathematical principles which are relevant to electrotechnical work tasks. Okay. Now, again, all we're doing here is just recapping prefixes are widely used, etc. BODMAS, BIDMAS, etc., etc. Blah blah blah, etc. You don't need me to read that out to you. You should be able to read that for yourselves. And I'm trying to make sure that it is clear and well lit. Okay. Now, introduction. Whatever level of engineering that you are studying, there is a need for some knowledge of mathematics. In engineering, I will know that bit because you can read that yourself. In engineering, there are generally three types of shape that we need to consider. These are square or rectangular. I would say rectangular, but rectangle, circle, triangle. The triangle in particular is useful as this is used in AC circuits to work out impedance and power properties. Okay. Okay. Yeah. Let's just see if we can get this in place. Okay. So okay, just have to make sure that the it's in view because sometimes when you play back the camera, it's not always where it should be. Okay. Even though it looks right on camera. Okay. Now squares and rectangles. Now I'm just going to take you down for a moment and show you what I'm looking at this point in time. Okay, just for a moment. Okay, I'm just going to take the camera down. Okay. Okay, and that's what I am looking at this moment in time. Okay. Well, I can't see it at the moment because I'm not viewing it from your perspective. Okay. But that's all I'm looking at this point, and that's what I'm going to be talking about a lot of. Okay. Let me just check something back for myself. Um, okay. Yeah, I'm there. We'll see how we run. Thank you. Okay, good. Squares have sides of equal length and breadth. Rectangles have sides that are unequal length and breadth. To find the perimeter, and remember what the perimeter is the area outside any object or field. We would add the total length of all the sides, b plus 1, b plus l, plus b plus l, or 2b plus 2l. Okay. To find the area, the total space inside the square or rectangle, we need to multiply the length by the breadth, L times B. Okay. Now again here, and just to show you again here what I'm looking at, important facts about circles. Okay, and I'm just going to take the camera down again and just to show you what I'm talking about for this moment in time. Okay. Okay, I'm hoping that my camera will show you overall. Okay. Okay. Putting the camera back. Okay. And let me just check to see if I am on in view still. Okay. Yeah, I'm still in view. Thank you. Okay. Good. Get my main camera now back in line for the presentation. The line around the outside of the circle is called the circumference. This is the name as the perimeter. This is the same as the perimeter. Sorry. A line drawn directly from one side of the circle to the other and crosses the center of the circle is called the diameter. And here you have your diameter. A line drawn from the center of the circle to any edge of the circle is called the radius. The radius is half the diameter. Okay. And now look at this. Pi, this symbol is called pi. It is an important tool when calculating anything to do with circles. Pi allows you to find the circumference of the circle if you know the radius or diameter, and allows you to find the radius and diameter if you know the circumference. Pi is given the value of 3.142. No units to it, okay? Now, pi for engineers is using as 3.142. If you use pi from your calculator directly, the answer you get is going to be somewhat different, okay? And you're going to find that when you come to do it in regards to electrical engineering, it can be way out. Okay, so you have to work within the criteria of 3.142, whether you're in the United States, the United Kingdom, France, or anywhere else. That is the standard to which we work. Okay. Now, looking at the circumference, okay, whatever the size of a circle, the number of times the diameter will divide into the circumference is always the same, just over 3.142. The ratio of this is given the symbol of pi. Pi equals 3.142. Now, the circumference of any circle equals pi times the diameter. We use C for the circumference, D for the diameter, R for the radius. So we have D equals 2 times R, C equals pi times D, or C equals 2 pi R. Now, why does that hit me as my head telling me that that's equal to pi R square? But it's probably something else that I'm just trying to, that I'm remembering. But we'll take as C equals 2 pi R, okay? And here we are on regards to triangles. Now again, this is not going to show you, you're not going to see what I'm looking at, but I'm producing a video for tells us about trigonometry, and I'm hoping that the video will present itself in a manner that is understood. A triangle is a three-sided figure. The angles of any triangle add up to 180. To find the area of a triangle, area equals base times height divided by 2. Area equals base times height divided by 2. Okay? Triangles have a number of other qualities. The extra qualities of right angle triangles are of benefit to us in the electrical industry. We will look at this in a moment. Here we're looking at Pythagoras theorem. Okay, call it Pythagoras theory, but for me it was Pythagoras theorem. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So what we're saying is that the square on the hypotenuse, that is your hypotenuse, this whole area here is equal to this and this area added together. Okay, that's what we're saying. Okay. Area equals 5 squared equals 25 units, or equals 9 plus 16 equals 25 units. And here's your 5, okay, 25. 3 squared is 9. 4 squared is 16. So we can see that if we take this here as 4 squared 16, 3 squared equals 9, we add these two together, it will come to 25. So therefore we know that, this area is equal to that area added together. Okay? That is the formulation that you will apply at all times. Okay? Now write this out for yourself and make sure you understand. Okay? The concepts behind it. What is the hypotenuse? A square has been drawn on the side of the triangle. If you were to measure the individual areas, the two areas of the squares add up to the area on the longest side. The formula for this is a squared equals b squared plus c squared, etc., etc., etc. The longest side is always the hypotenuse. Okay, it does not change. I can turn it upside down, I can turn it around, any way you like, it will still be the hypotenuse. I can shake its legs and it will still be the hypotenuse. Okay, calculating right angle triangles now. The intentions here is, if we know two sides of a right angle triangle, we can always calculate the length of the third. The angle opposite the longest side is always 90 degrees. Okay, now, when we talk about angle opposite the longest side, we're looking at something like longest side, and this here is 90 degrees. Okay, so that's what we're looking at basically. Let me show you. Can I get this into it? Yep. Okay, that's what we're looking at. Longest side. Okay, and the side opposite is going to be 90 degrees. Okay. It's okay. I'm just doing a little bit of rough work while I go along. Okay. Now here you have Pythagoras theorem can be written as, okay, I'm not going to read this out to you because at this level now you should not be able to do that yourselves and be quite familiar with it. I've presented enough mathematical calculations and information already for you to be able to do this yourselves. If not, look back at what I've done. Right angle triangles, okay? In a right angle triangle, the longest side is the hypotenuse, the side opposite, the angle is the opposite. The side next to the angle is the adjacent, which means next to. Okay? This side is adjacent to the right angle, okay? And let's just see if we can bring it in closer for you to see. Yep. If we can. Let me just go up a little bit. A little bit more, can I get you into there? Yep. Okay. Okay. And you have sine, cosine, tangent, etc. Okay? Nothing more on that to do. So let's have a look. And here we have ratios of right angle triangles. Now opposite sine equals opposite side of angle over hypotenuse. And that's how it's written. Cosine equals adjacent side of angle over hypotenuse. And that is how it is written. Tangent equals opposite side of angle over adjacent side of angle. And that is how it is written. Okay? These can be remembered as SOHCAHTOA. SOHCAHTOA. Okay? And let me just move into that so you can see that for yourselves. Now, again, you guys can't see what I'm looking at, but when you look at the video in regards to trigonometry, you will recognize what I've been talking about, okay? Okay, let's look at an example. Find the angle in the triangle, write down the words SOHCAHTOA, mark each of the known sides, okay? We have one side known, two sides known, okay? From above, the only word that links the two letters marked with the angle is TOA. Tangent equal opposite over adjacent equals 24 over 20 equals 1.2. No, why 24? Where did 24 come from? There could be an error in my diagram. Unless I've missed something. Okay, if I have missed something, sure you'll let me know in due course. So we're having a look at opposite over adjacent. Which should be 30 over 20. This should be 30 over 20. So I have no idea why we've got 24 over 20. It's possible an error, okay? But if it's opposite over the adjacent, then it has to be 30 over 20. So please bear that in mind. I think there's an error here in my working out at this point in time. So it happens. So make sure that you have applied the correct principles of calculation and solution, and make sure that you have understood the concept of SOHCAHTOA. Okay. But I believe there's an error here, but I'm not going to rectify it now. I'll live with my errors and mistakes because I'm not perfect, and I make no excuses for that in any shape or form. I'm just handsome and good looking. Okay. Now here we've been asked to solve the following. Find A, the length, Y, and Z, the area. Okay. And let's look at what we need to do then. So I'm going to leave that there for a moment for you to look at it and to see if you can find it. Now remember, it doesn't matter that it's still the hypotenuse. It doesn't matter what it looks like, upside down or twisted or whatever. It will remain the hypotenuse. What we have here is the angle of 30 degrees. We need to decide how we're going to utilize that to bring about a solution to our problem. Okay, let's have a look at it. Here we're looking at cos theta. I call it cos theta equals 10 over z. Therefore, z equals, we are looking for z. We know the angle. Z equals 10 over cos theta. So we're finally looking for the cosine of 30 degrees. Okay. And when you find the cosine of 30 degrees, it comes to 11.547. Now, again, I allow for the fact that there might be an error in my calculations, and I accept that, okay? When you're doing these things in a rush, you don't always get a chance to correct them as you would like, okay? And again, tan here, therefore y, we're looking for y equals 10 times tangent 30 of 30 degrees. And again, here we have 5.774. Now again, area equals half the base times height. Okay. And the remaining part, question 2. Question 2. I'm sorry. Let me just go back a little bit because I did not see my question. Yes, I see my question 2 now. Thank you. Okay. Yes. After you're talking for a while, these things run into each other. So here, make sure you write this out and you understand how they got the values of z equals x squared plus y squared. Okay, you then need to put these values in. Y yx 45 degrees, and again you're looking at and it's mentioned in here x remains unchanged. z equals x squared plus y squared. Now again, you remember earlier we mentioned a squared equals b squared plus c squared, etc. That is what you're looking at here, but you're bringing it in to find a given value, having been given some information in regards to the question being asked. Okay. And I'll leave it there for you. I don't want to be doing this for you because it will defeat the object of you writing these out for yourselves and doing them for yourselves. Okay. Make sure you write this out. Now x squared equals 10 squared plus 8.3723 squared. And for my question for you is, where did we get the 10 squared from, and where did we get 8.372 squared from? Okay, those are bits that I think you should need to look at, aware of. Just ask yourself how it came about, make it your business to find out. Okay, right. Thank you. Have a good day, and I hope you found this useful. Okay. Okay. Thank you. Bye bye.